It happens without warning. A song you've heard 100 times reaches a particular moment, a chord shift, a voice that cracks slightly on a high note, a passage of music that seems to arrive from somewhere outside the song itself, and suddenly your skin rises. The hair on your arms stands up. A wave moves through your chest and up the back of your neck. You didn't choose for that to happen. You didn't decide to feel it. It arrived before you could prepare for it. Scientists have a name for this. They call it frisson. And it is one of the strangest, most counterintuitive, and most revealing phenomena in all of human psychology. Because what frisson tells us about the human brain, why it happens, when it happens, what it requires, rewrites something fundamental about what music actually is, and why your species developed the ability to feel it at all. Let's start with the obvious question: what is actually happening in your body when a piece of music gives you chills? The answer begins in a place you wouldn't expect. It begins in your threat detection system. When something dangerous happens, when a loud sound erupts from behind you, when a shadow moves unexpectedly, when a predator appears at the edge of your vision, your nervous system triggers a specific cascade of physiological responses. Your heart rate accelerates. Your breathing changes. The erector pili muscles, which are attached to each hair follicle, contract, pulling the hair upright, which in mammals with thick fur was a way of making the body appear larger to a threat. In humans, who have very little body hair, this reflex produces the visible surface of goosebumps. This response is ancient. It predates mammals. It predates the neocortex. It predates language, music, and abstract thought by hundreds of millions of years. And music is somehow triggering it. Not because your brain is confused about whether a chord progression is a predator, but because the same neural machinery that evolved to respond to the unexpected, the significant, and the emotionally charged in the physical world has been co-opted, or perhaps more accurately, has co-opted music, to serve an entirely different purpose. The neuroscientist who has done more than anyone to understand what's happening in the brain during musical frisson is Robert Zator at McGill University. Zator and his colleague in Blood published a landmark study in 2001 in which they used neuroimaging to watch the brains of people experiencing chills from music in real time. What they found was remarkable. When a listener experienced frisson, the parts of the brain that activated were not the auditory cortex, not the parts of the brain that process sound. The parts that activated were deep, ancient, subcortical structures, the nucleus accumbens, the ventral tegmental area, the amygdala. These are the same regions that activate when you eat food you're hungry for, when you take an addictive drug, when you have sex, when you expire. It's any reward your biology has been programmed to pursue. In other words, music was triggering the dopamine system, the oldest reward circuit in the mammalian brain. This wasn't a minor activation. In Zator and Blood's data, the intensity of brain activity in the nucleus accumbens during musical chills was comparable to the activity observed during other peak biological rewards. The brain, in those moments, was treating a sound as something genuinely significant, as something worth learning from, as something it needed to remember. But why? What is significant about a chord shift? Why would the brain's most ancient reward circuits respond to the particular arrangement of sound waves? Here is where the story becomes strange and interesting. Your brain, it turns out, is fundamentally a prediction machine. Every waking moment, it is running models of what is about to happen, what you are about to see, hear, feel, and experience, and comparing those predictions against what actually arrives. This happens at every level of processing, from the most basic sensory input to the most complex social reasoning. The brain doesn't passively receive the world. It actively anticipates it. Neuroscientist Carl Friston, who has spent decades developing what has become one of the most influential theories in modern neuroscience, calls this predictive processing. The brain, in Friston's framework, is constantly generating hypotheses about the world and updating them when the world surprises it. The feeling of surprise, of prediction error, is not merely neutral information. It is a signal that the model needs updating. It carries weight. It demands attention. Now bring that framework to music. Music is essentially a highly structured system of expectation and surprise. Every musical tradition, from Bach to blues to Bollywood, operates by establishing patterns and then doing something unexpected with them. A melody creates a set of expectations about where it's going to go, and then subverts those expectations in a way that is surprising but, crucially, still feels right. A rhythm sets up a pulse and then syncopates it. A harmonic sequence builds toward a resolution and then delays or redirects it. When the surprise arrives in exactly the right way, when the expectation is violated in a manner that is unexpected but deeply satisfying, the brain's prediction error signaling system fires. And that signal, in the right emotional context, in a listener who has the right relationship to the music, cascades into the dopamine system. The brain registers, something important just happened. Something worth feeling. This model was explored in detail by music psychologist David Huron at Ohio State University, whose 2006 book on music and expectation remains one of the most important works in the field. Huron argued that musical emotion is fundamentally about the interplay between what we expect and what we get, and that the brain's response to that interplay involve the same circuits that evolved to help animals navigate a world full of genuine threats and genuine rewards. But here is the twist that most people don't know. Not everyone gets chills from music. Research suggests that somewhere between 50 and 70% of people experience frisson at some point in their lives. But a significant minority never do. They can love music, appreciate its complexity, feel emotional in response to it, but the physical, skin-raising, chest-flooding response simply doesn't happen for them. The people who are most likely to experience frisson, research has found, share a particular set of psychological characteristics. They tend to score high on a personality trait called openness to experience, a trait associated with curiosity, imaginative engagement, and a willingness to be moved by art and ideas. They tend to have unusually dense connections between their auditory cortex and the emotional processing centers of the brain. And they tend to engage with music in a particular way, not passively, as background, but actively, as something that deserves their full attention. Matthew Sachs, a researcher at the University of Southern California, used brain imaging to compare the neural architecture of people who frequently experience frisson with those who don't. He found that the chills experienced group had structurally more connections between the auditory cortex and the regions associated with emotional processing and reward. The brain's people who get chills from music are, in a literal anatomical sense, more integrated. The distance between hearing and feeling is shorter. What this suggests is profound. The experience of frisson is not simply a response to music. It is a response that depends on a particular kind of brain, one that allows sound to travel quickly and directly into the emotional system. And that architecture, once you have it, means you process music differently from the ground up. Not just more emotionally, but more deeply, more predictively, with more of the brain's resources devoted to anticipating what comes next and registering what arrives instead. But none of this fully explains why music exists at all. Why would humans develop the capacity to be so deeply moved by organized sound? The evolutionary question is one that has occupied researchers for decades and remains genuinely unsettled. Charles Darwin himself was puzzled by music. He called it one of the most mysterious abilities of humanity, because he couldn't find a clear survival function for it. Unlike language, which transmits information, or tool use, which manipulates the environment, music seemed to exist primarily to produce feeling. And producing feeling, on a strict adaptationist account, doesn't obviously make you more likely to survive. Several compelling theories have emerged. Robin Dunbar, the evolutionary anthropologist whose work on social bonding has already reframed how scientists think about laughter and language, has argued that music evolved primarily as a social synchronization tool. When groups of humans sing or move together to a common rhythm, something happens in the brain, the release of endorphins, the same chemicals involved in social grooming among primates, and in the bonding responses of mother and infant. Music, in Dunbar's account, is a technology for creating the neurochemical state of social bonding at scale. It allows large groups of humans to feel connected to each other simultaneously, something that grooming, which requires physical contact, cannot achieve beyond small numbers. This theory helps explain why music is found in every human culture, across every period of recorded high story, and why it is so reliably used at precisely the moments when social bonding matters most: births, deaths, rituals, celebrations, the preparation for collective action. And it helps explain something else: why the chills you feel during music are most intense when you feel emotionally connected to the music, to the moment, or to the people around you. Frisson isn't just about the music. It's about the relationship between the music and something larger, something that feels like it matters. The brain's ancient reward system isn't responding to sound. It's responding to meaning. There's a particular piece of music playing somewhere right now. Maybe it's already inside your head, a song that has given you chills before, a passage you know will do it again. When it comes to that moment, when the hair rises and the wave moves through you, you're not having a reaction to organized air pressure. You're having a reaction that links your auditory cortex to the oldest reward systems in the mammalian brain, that activates the same circuits as hunger and connection and the recognition of something important, that evolved alongside the capacity to be together, to move together, to feel together. Music didn't give you chills because something was wrong. Music gave you chills because something was right.